Let me check when you finish if it's connected.
What do you do? Bring me to the
Hello, good morning. Welcome to OG's Wealth of Math. In this video, we are going to start with indices, and then we'll move to exponential equations. So I'm going to teach you everything you need to learn about indices for today. All right, so we're going to see now. You need to watch my first two video, in algebraic processing, so that it will help you understand how to solve problems in indices. All right. Now, for the laws of indices, I know that what is an index form? You need to know what an index form is. If I have, like, in your elementary school, you're often asked to express 8 in index form, if you remember. So this 8 will be 2 times 2 times 2, which will be 2 to the power of 3. So that shows that an index form is any form that has a base and a power. All right, so 2 represent the base and 3 represent the power of 2. So this is an index form. So when you have multiple of this form, you talk about indices, which is plural. All right, now we are going to start with the product law. So number one, we're going to talk about the product law. Now, product simply means multiplication. So when I'm multiplying, when I'm looking for the product of two index form, for instance, like a to the power of x times a to the power of y, this is product. And the law states that when you're multiplying, indices with the same base, look at the underlining word is same base, underlining phrase, same base. So if they have the same base, all you need to do is to take one of the base and then sum their power. That will be the result for this expression. So my result will be a to the power of x plus y. Now, if I have a to x times a to y times a to z, what do you think the result will be? Okay, it will be a to the power of x plus y plus z. Now, the law does not exist if I had a to the x times b to the y. Now, if you look at this, this is the first question, the second, and the third. Now, for the third question, you can see that they do not have the same base. So the law is not valid in this situation. All right? So what you need to do in a case like this is to, you just write a to the x and b to the y. So that is just what excuse me. All right, sorry about that. So you have a to the x and a to the y. So the law is not valid in this situation. All right. So the law is not valid. So we'll move to sorry. Okay. Now the law is not valid in this situation. All right. So let's take let's take few questions. I have a 5 raised to the power 3 times 5 raised to the power 7 times 5 raised to the power 10. Now, if you look at this, they all have the same base. So all I need to do is to pick one of the base and then I'll add up their power. 3 plus 7 plus 10 will give me 5 to the power of 20. So that's the answer. All right? So you can have 2x to the 5 times 3x to the 2 times 4x to the 7. So in this case, you can see these are the initial form. These are indices. So all I need to do, I'll first of all multiply by their coefficients. 2 times 3 is 6. 6 times 4 is 24. Then I'll take one of the base and then I'll sum their power. So I have 5 plus 2 plus 7. That will give me 24x to the power of 14. All right, that's pretty simple. So let's move to the next one. It is called the quotient. All right, the quotient or division. Quotient simply means division. Now, for products, we add their power. For quotient or division, we subtract their power. So let's go quickly. So if I have a to the x divided by a to the y, then my result will be a to the x minus y. It's as simple as that. All right? So if I have a to the x divided by b to the y, now if you look at this, they do not have the same base, so the law will not exist. So you just leave your answer as a to the x then divided by b to the y. So this becomes your result. So let's solve some practical question. 12x to the 7 divided by 4x to the 3. That will give you 12 divided by 4 is 3. So I'll take one of the base, take one of the base and then find the difference of their power. So this will give me 3x to the 4. All right? So that's all about the division law. All right? Now we want to move to what is called the negative power. Now for negative power, there are two conditions for negative power. The first condition is that if I have a negative power with a whole number base, for instance, if I have a raised to the power of minus x, and then I have another condition, a over b raised to the power of minus x. Now you can see that these are two different situations. So for the first scenario, the expression will be different from the second scenario. So you can either have an index form, whose for negative power, whose base is a whole number. In this case, the base is a whole number. In this case, the base is in form of a fraction. So for a whole number base, the negative power will become 1 divided by, then you reproduce everything you have, a to the x. So that's your result. So for the second condition, for fractional base, the negative sign would disappear, and then the fractional base will become the inverse. In other words, it becomes b over a. That's the inverse. So I have raised to the power x. So this is the expression. So let's take example in a situation where I have 2 raised to the power minus 3. This will become 1 over 2/3. So which will be 1 over 2/3 is 2 times 2 times 2, which is 1 over 8. But you can leave your answer like this, 1 over 8. The second condition, let's say we have 3/2 all raised to the power minus 2. So for this is a fractional base. So the negative goes away, and then the fraction becomes 2/3. This is 3/2. The fraction becomes 2/3. Becomes the inverse. In other words, you flip this, and then the negative disappears. You have this. So this will be 2 to the 2, 3 to the 2, which is 4/9. So that's pretty simple. So that's how to solve problems with negative power. All right? So without wasting time, we've seen 3 of the laws. Now I want to see the zero power law. Now in the zero power law, the law states that any base to the power of 0 is a 1. If I have a to the 0 is a 1. So in a situation where I have 3x plus 1 divided by 3x, let's say 3x minus 1 divided by 3x, 3 raised to the power x minus 1 divided by 3 raised to the power x plus 1. So what are we going to do? How are we going to go about this? So for this, they have the same base. The laws say that you should take one of the base, so I'm going to do 3 to this power x minus 1. Then this division means minus into bracket x plus 1. So this will give me 3 to the x minus 1. This is like saying minus 1 here outside the bracket. You can watch the previous video. So minus 1 times plus x will give you minus x. Minus 1 times plus 1 will give you minus 1. All right. Okay, what I actually wanted is this should be a minus. So if you do minus 1 times the minus 1 will give you plus 1. So in this case, we will have, so we'll have 3 to the, this is x minus x, x minus x. This is minus 1 plus 1. So x minus x will give you 0. Minus 1 plus 1 will give you 0. So I have 3 raised to the power 0, which will finally give you a 1. So that's that about the negative power law. All right. So I hope you're getting what I'm teaching. So let's move to the next one. We want to see the fractional power law. For the fractional power law, there are 2 forms of it. Where you have a denominator, where you have your numerator as 1 over, when you have your numerator as 1 over y, and the second condition is a raised to the power x over y. I will explain the two conditions for you. For this one, you can see that our fractional numerator is a 1. Here, our fractional numerator isn't a 1, a number greater than 1. That's what x represents here. So this is a case where the fractional numerator is a 1, and here the fractional numerator isn't a 1. So for fractional power, please listen very attentively. What you do is that your fractional denominator becomes the root of your base, then all raised to the power of the numerator. Do you understand? I'll say that again. For a fractional power, your fractional denominator, the fractional denominator is 1 in this case, and the fractional numerator is 1. So the fractional denominator becomes the root of the base. So it becomes the y root of a all to the 1. But because 1 has no effect on multiplication, on division, and on exponential, so we don't need to put the 1 here. What I meant is that if I say 5 raised to the power 1, I'm going to get a 5. 5 multiplied by 1, I'll get a 5. 5 divided by 1, I'll get a 5. 5 has no effect on multiplication, division, and exponential, raising power. If you raise anything to the power of 1, you're going to get that thing. If you multiply anything by 1, you get that thing. If you divide anything by 1, you get back that same value. All right? So for the second condition, the fractional denominator, which is the y root of a, all raised to the power of, um, sorry, all raised to the power of x, the numerator. All right, let's take practical example. In a case where I have 8 raised to the power of 1/3, and then 8 raised to the power of 2/3. In this case, my fractional denominator will be the third root of the base, which is 8, all raised to the power 1, but I don't need it because 1 has no effect. So the third root of 8 will just give me 2. You can punch that, you can put in that in your calculator. For the second question, the fractional denominator, this is the third root of 8, all to this 2 power. Now the third root of 8 will give you 2. Now 2 to the power of 2 will give you 4. All right? Let's take more problems than that. Let's take more problems than that. Now, let's say we have 27 over 1000 to the power of 2/3. Okay, let me use negative 2/3. Now, if you look at this, you can see that there are two laws that exist in this question. You have the negative and the fractional power. So the negative power, I told you that the negative power has two conditions. The second condition, the first condition is when you have the whole number base, and the second condition is when you have the fractional base. In this question, we have the fractional base. All right? So because we have the fractional base, the fraction will become the inverse. In other words, it will flip to 1000 over 27, and the negative sign disappeared. So we've been able to deal with that. So we'll have our new expression will be 1000 over 27 to the power of 2/3. So this guy disappeared. The negative sign goes up rather. Now the next thing is my fractional denominator will cover, because my base is actually 1000 over 27. So the fractional base will cover everything. So the third root of 1000 over 27 all to the power of 2. Now the third root of 1000 is 10, because 10 times 10 times 10 will give you 1000. And the third root of 27 is 3, because 3 times 3 times 3 will give you 27. So all squared, which is 10 squared, 3 squared, which is 100 over 9. All right? So that's how to go about that. All right? So without wasting time, I think we are good to go with this. So we want to see another law, which is called the double power, or you can call it the raising power. All right? Now I call it double power in a case where you have, let's say we have x raised to the power y, x raised to the power 3, y raised to the power 2, z raised to the power 4, all squared. Now if you look at this, now this in a real sense simply means you're multiplying everything here by itself. But wait a minute, what about if this is 100? Would you do that? Would you multiply that in 100 places? No, you won't do that. So there's an easy way to do that. So when you can see that all of this has its own power, this has its own power, this has its own power. This is another power. That's why I call it double. This multiplied by this multiplied by this multiplied by this. So I'm considering each of the variables, in that expression. So for double power, all you need to do, just multiply their power. That's all. Multiply what you have outside by the power inside. So that means x to the 3 times 2 multiplied by y to the 2 times 2 multiplied by z to the 4 times 2. So that will give you x to the 6 times y to the 4 times z to the 8. So everything will be x to the 6, y to the 4, and z to the 8. It's pretty simple. All right, so let's take more difficult questions. Let's say we have 32 raised to the power x to the 5, y to the 10, and z to the 15, all raised to the power of 1/5. Now, if you look at this, you can see that I actually have double power. This power multiplied by this. So I want to multiply each power. So for 32, 32 has the power of 1. So if I multiply 1/5 by 1, I'm going to get 1/5. So now my new expression will be 32 raised to the power 1/5 multiplied by x raised to the power 5 times 1/5 multiplied by y raised to the power 10 multiplied by 1/5 multiplied by z raised to the power 15 multiplied by 1/5. All right? Now, what you're going to do here, so in this case, you can see that I have a fractional power. If you remember that fractional power law, the fractional power law states that your fractional denominator becomes the root of your base. So in this case, my fractional denominator is 5, so it becomes the 5th root of 32. So the 1 is not, it won't add any meaning. Multiply by, this will be 5 times 1 is 5. 5 divided by 5 is 1. So I have x raised to the power 1. But I don't need to write x raised to the power 1. X represents x raised to the power 1. Multiply by 10 times 1 is 10 divided by 5 is 2. So y raised to the power 2. Multiply by 15 times 1 divided by 3, divided by 5 will give you z raised to the power 3. So finally, the 5th root of 32 will give you a 2. Then I have 2x, y squared, and z3. So that is pretty simple. So that's how to solve that. So you can copy that quickly. Now we've seen the fractional power law. Now we want to see okay, you can copy that quickly. So we want to solve some questions very quickly, we've seen the product law, the quotient, the zero power, the negative power, the double power law, and then we've seen the fractional power law. All right, so let's see how we can apply them in solving a problem. Okay, let's presume we have 5x3 times 2x7. So I want you to do that and give me the answer quickly. We are rounding up 8x7 divided by 4x5. 15x3 divided by 25x7. Now let's see how we can solve these few problems. Now, if you look at this, for this, just give me the answer straight away. The answer will be 10x to the 10. For this, the answer will be 2x to the 2. For this, now, you can see that this will give you a fraction. If you do 15 over 25 will give you 3 over 5. So 15 over 25, you take one of these, x to the 10 minus 7. So this will give me 3 over 5, x to the negative 4. So what are you going to do? This is negative power. So this means 3/5 multiplied by, this becomes 1 over x to the 4. So this is 3 over 5x to the 4. So that's how to solve this problem. You can see what I did. So you don't stop, you don't leave your answer here, because you need to simplify it. This is part of the law, negative power law. All right. So that's that about that. So for the number 4, so you can copy that quickly. Number 4. This will be the 4th root of 81. I think it's 3. 3, 3, 3, 27 times 3. 1, 2, so 81. So the answer is 3. And then for this, now for this, a lot of you might have problems solving this in the radical form, or in the radical form, or in the root form. So it is better you take it back to exponential form, which you understand. So this can be expressed as 64 x to the 9, y to the 12, all to the power of 2/3. So this is another expression for this. All right. I know a lot of students might get confused about this. Right. Well, I prefer you, whenever you have any exponential form, any initial form, sorry, in the root form, just take it to this form. All right. So here, what we need to do, we'll talk about the double power. So multiply each power by what you have outside the bracket. If we do that, we have 64 raised to the power 2/3 multiplied by x to the 9 multiplied by 2/3 multiplied by y to the 12. You multiply that by the power by 2/3. So we are multiplying by the power. So take note of that. So this will give us the fractional denominator becomes the 3rd root of 64 all squared multiplied by, so this is 2 times 9 times 2 is 18. 18 divided by 3 is 6. So I have x to the 6 multiplied by, this is 2 times 12 times 2 is 24. 24 divided by 3 is 8. So y to the 8. All right. So my final answer could be the 3rd root of 64 will give me 4. 4 squared multiplied by x to the 6, y to the 8. Now, 4 squared is actually 16. So 16x to the 6, y to the 8. So that is my answer. So let's take this one, the last question, and then we are done with this class. So for this, we have 8 x to the 6. So there are 2 ways we can do this. So it all depends on what you want to do. We can decide to reduce we can decide to reduce this first of all, or we can just solve, we can decide to reduce that first of all. So by saying, okay, 2 to 2/3 multiplied by x raised to the power 6 times 2/3 multiplied by y raised to the power 9 times 2/3 all over, I'll do the same thing for the denominator, 27 2/3 multiplied by x raised to the power 3 times 2/3. All right, so you can see this becomes the third root of 8 raised to the power of 2 multiplied by, so this will give me x raised to the power 6 times 2 is 12, right? 12 divided by 3 is 4. So that will be x raised to the power 4 multiplied by, this is 18 divided by 3, so y raised to the power 6. Then all over, this is the third root of 27 all squared multiplied by this. So this will give me 2. I can cancel out this, so x to the 2. All right? Now, here, the third root of 8 is actually 2. So 2 squared, sorry, this is 2, then raised to the power 2 multiplied by x to the 4, y to the 6, then divided by, this is 3, x to the 2. All right, so here, finally, we have 4x to the 4, y to the 6 over x, 3x squared. So you can see that this is more like saying, if you want to go by the law, I can say 4 over 3x to the 4, y to the 6 divided by this. Or I can cancel out, this is x in 4 places. We have x to the 4, x to the 2 denominator. So if I cancel out x to the 2 and I take x raised to the power 4 is x to the 2 dot x to the 2. So this will cancel out this, so I'll have, so I can go straight to my answer here. So this cancel out 2 of this, so I have 4x to the 2, y to the 6 over 3. So that's my final answer. So we've come to the end of today's class, so you can subscribe to my channel, and please leave your comments on the comment section. Share the links, do you understand, to your friends. Share the links to people who are struggling with math, and have a great day. Thank you for watching my video. Bye.